So the first problem is an addition problem. This is addition. Can you add two complex numbers together? Well, when you're adding complex numbers together, it is the same as when you're adding things that are like x's. And so, one thing you may remember from algebra class is that if there's a plus sign, that's like distributing a 1. So you don't need parentheses right there. So this is really just minus 3 minus 5i. And then here, because there's no number in front of the parentheses, you don't really need them. So I'll put 4 plus 2i. If this was a minus sign, you would distribute it in, and that would become a plus 3 and a plus 5i. So if this is an operator of minus, you distribute it in. From there, combine like terms. So, and we always put the real part first, because that's standard form. So I'll put the 4 with the minus 3, and I know 4 minus 3 is 1. I know also that 2i minus 5i is minus 3i. This is what we call a complex number. It's complex because it has the real part and the imaginary part. And what's nice about your calculator, if I could type this in, 4 plus 2 I plus negative 3 minus 5 I 1 minus 3i. See, same thing. Okay. Now what button did I use? The I is the decimal. See, the I is in yellow. You have to hit the okay, on here, this is an example of multiplication. It's multiplication because you got the expression 3 minus 2i times the expression 5 plus 4i. And one thing we need to know before we start is that I squared, if you take an I times an I, you get negative 1. So two i's together make negative 1. And that's going to be important in this problem. So this is called distribution. Your teacher may have taught you different ways. Some teachers teach you to make a table. Some teachers teach you to just distribute. Some say FOIL. But essentially, you just take the 3, distribute it to the 5. 3 times 5 is 15. You take the 3, distribute it to the 4i. 3 times 4i is 12i. And then once you're done distributing the 3 to everything, you go to the next term, negative 2i. You distribute that to the 5. That's negative 10i. And then finally, you take negative 2i times 4i, which is negative 8i squared. Okay, from there, we're going to combine like terms. And actually, before I do that, I'm going to use the fact that I squared is negative 1. So this becomes 15 and 12i minus 10i minus 8, and I squared, by definition, is negative 1. Alright, from there, I'm going to do the real number part. So I'd go 15, and this is actually plus 8. Negative 8 times negative 1 is plus 8. So 15 plus 8 is what, 23? And then the imaginary part, 12i's minus 10i's is 2i's. And standard form is to put the real part and then the imaginary. We call that complex. Now if I wanted to, I could type this in my calculator. But if I wanted to, I could type this in the calculator and notice 23 plus 2i. And if you see what we got was 23 plus 2i. So you can do all of this on your TI-83. Here's an example of division. Now, when you're dividing, the goal here is to get the I out of the denominator. So when I say denominator, I mean the bottom of the fraction. And so to get the I out of the denominator, we multiply by something called a complex conjugate, and I'll write that down. And what that really all it means is that instead of a plus sign, you're going to use a minus sign. So you're going to multiply this by 5 minus 2i. Now you can't just multiply the denominator by 5 minus 2i. You have to do also the numerator. Or else you're changing it. Now 5 minus 2i divided by 5 minus 2i is 1. And when you multiply by 1, you get the same thing. So I did not change anything. If this was a minus, this would be a plus. So the complex conjugate of 5 plus 2i is 5 minus 2i. The complex conjugate of 5 minus 2i is 5 plus 2i. So from here I need to distribute. So I'll go 1 minus 5. That's 5. Or 1 times 5. Sorry about that. And then 1 times negative 2i is negative 2i. And then I distribute the negative 4i to the 5. Negative 20i. And then the negative 4i times the negative 2i would be 8i squared. Okay, we also need to distribute the denominator. So 5 times 5, 25. 5 times negative 2i is negative 10i. And then we distribute the 2i to the 5. That's 10i. And then the 2i times the negative 2i would be negative 4i squared. Now one thing I want you to notice is that these are opposites. Why are they opposites? Because we multiplied by the complex conjugate. Anytime you multiply by the complex conjugate, these two will be the same, therefore they will go away. From there, I'll copy down the 5. I recognize that these two, negative 2i minus 20i is negative 22i. And then I'll recognize that this would be plus 8, but I squared is negative 1. Divided by 25. Those canceled, which is what I wanted, minus 4 times negative 1. From there, let's simplify. So that'd be 5 plus negative 8. 5 plus negative 8. What, negative 3? And then the minus 22i stays there. And then here, this part would be what, 25 plus 4? 29? Now, some teachers are happy with that. I know the standard form would be to break that up. So to break that up, you would say that equals negative 3 over 29 minus 22 29 I. Now the reason why we do that is because the complex form is the real number and then the imaginary number. But you'll see it written like this, or you may see it written where they take the denominator and break that over two fractions. Now what's kind of cool is I can also type this into the calculator. And I'll move this here in a second. So the problem was, I have to type it in parentheses, 1 minus 4i divided by 5 plus 2i. It spits out the answer in decimal form, but I could go math, enter, enter, and there we go. Negative 3 over 29 minus 22 over 29i.